going to go over how to complete 3B, question 3B. So let's go ahead and go through this. So 507 business students were surveyed. 333 indicated that they used an Apple operating system for their computer operating system, while 146 indicated that they utilized Windows. It's believed the individuals who utilize an Apple will be more satisfied with their operating system. The standard error of the difference is the difference between the standard error of Apple users and Window users. So you see right here, the standard error of the difference is the difference between Apple users and Window users. We have this information because the variances were not pooled. So you notice down here, the F-test for the equality of variance, it says that the variances are not the same. You see 0.0019, that means that the variances are not the same, the distributions are very different, and because of that, we are going to be doing this assessment with non-pooled variances. And because of that, you can see the standard error is different. So that's just a little bit of information for you. So when you see this extra information, you'll know what that is. Okay, so based on the following results with an alpha of 0.1, what can we determine about the student's satisfaction with Windows versus Apple OS machines? Okay, so we've got the results right here. First of all, I really should ask, what tale of test is this? Here, let's do this. Null and alternative hypothesis. Null and alternative hypothesis. And then we'll do tale of test. And so we look at this right away, and we know, okay, 507 business students, Windows is believed to it is believed the individuals who utilize an Apple will be more satisfied with their operating system than Windows. So we know right away that the tale of tests that we have, because it says Apple will be more satisfied, we know that this is a one tail upper. Okay, one tail upper test. Okay, so let's just go ahead and put this in red. So you notice right here it says Apple will be more satisfied, so that means that we're comparing Apple to Windows. We're putting Apple first, and then Apple is going to be it's going to be a one tail upper tail test, and we're looking and assuming that Apple is going to be more satisfied than Windows. Next, let's go ahead and do the null and alternative hypothesis. I'm going to just go ahead and do this. Let's see here. So the null hypothesis says, whoops, this is the wrong way. The null hypothesis says that Apple is less than or equal to, or the mean of Apple is less than or equal to the mean of the Windows users. And then right here, the alternative hypothesis, what we expect to happen is the mean of Apple is greater than the mean of Windows users. So we've got the null hypothesis, we've got the alternative hypothesis. This is what we expect to happen, and this is what's going to happen if we fail to reject the null hypothesis. So in other words, it's going to say that it's equal. So next, what is the level of significance? If you look right here, alpha of 0.1, that means that the level of significance is 0.1. And also if I ask you, what is the alpha level? The alpha level is 0.1. What is the probability of type 1 error? The probability of type 1 error is 0.1. All three of these are the exact same thing. Okay, next thing is what is the test statistic? So right here we can see that the test statistic that we're using is T. Okay, so we're going to put T. And so T is the test statistic. But why is it the test statistic? So we've got 231 degrees of freedom. if you look at the t-chart, the t-distribution chart, we really could have used a z distribution, but we're going to use a t-distribution because we only have sample data. But for all intents and purposes, the sample is so large that we could have used a z distribution. Okay, so you can say we could have used a z, but we only have sample SD or sample. Let's do, I like using the symbols. There we go. The sample standard deviation. So next, decision rule. And I did, for some of y'all, you have different sheets than what's in front of you, so I just kind of changed it a little bit. But this is going to make it a little bit more, a little easier to follow along with. So first of all, what is the critical value? The critical value we're going to find on the t-distribution. And so I'm going to pause this for a second, and I'm going to pull up the t-distribution. Okay, so I've got the t-distribution right here. And you notice we've got an alpha of 0.1. So if you come right up here, you see level of significance for a one-tailed test. We've got an alpha of 0.1 for a one-tailed test. And we are going to go all the way down to the bottom. And we're going to see with degrees of freedom, with infinity, it's 1.282. So infinity, because it's above 200, so we're just going to go with infinity, and it's 1.282. And that, once again, is the intersection between 0.1 and infinity. Okay, 1.282. And it's going to be positive because it's an upper tail test. So 1.282. So what is the decision rule? The decision rule is going to be, okay, if the t-value, if the t-calculated value is greater than 1.282, we are going to reject the null hypothesis. Notice right here I put the t-critical value, 1.282 is right there. And so if it is beyond or more extreme than 1.282, we are going to reject the null hypothesis. If it is less than 1.282, we are going to fail to reject the null hypothesis. Okay, so if t is less than or equal to 1.282, fail to reject the null hypothesis. Next, decision. What is the value of the test statistic? So we look over here and we see t and we see 1.563. So 1.563 is the value of the test statistic, 1.563. And so I also put 1.563 right over here for t-calc. So we can see right away 1.563 is beyond t-crit, but we're getting a little bit ahead of ourselves. Next thing that we're going to do is what is the p-value? Let's take a look at the p-value. Notice there's a p-value down here. This is not the p-value that we're using. This is the p-value for the f-test. We also have a p-value for a two-tailed test. This is not a two-tailed test. This is a one-tail upper-tailed test. So the one that we're looking at is this one right here, 0.0597. Okay. So let me just put this right here, 0.0597, or you can put 0.0597. And so now what is our decision? Our decision is going to be, we reject the null hypothesis. And there's two things that we can look at to determine that. We can either say that the p-value is less than the alpha, so you compare the alpha to the p-value. If the p-value is less than the alpha, then we can say that we reject the null hypothesis. Also, we can reject the null hypothesis because the t-calculated value is more extreme than the t-critical value. So those are the two things that we can look at to make that decision. Finally, we're going to interpret our results. And before we do that, I'm going to, there we go. I'm going to control it. And let's interpret our results. And what we're going to do to interpret our results is we're going to say the results indicate that there is moderate evidence that individuals who utilize an Apple operating system are more satisfied with their OS than individuals who utilize a Windows operating system. Remember, if it is between these are the thresholds, right? You've got, if it's below 0.1, you've got moderately. If it is below 0.05, you can say strong. And if it is below 0.01, you can say extremely strong. Strong evidence. And so because this is below 0.1, but it's above 0.5, we're just going to say moderately strong, or there's moderate evidence that the individuals. That means that there's some evidence, but there's really a decent chance. I mean, there's a 5.97% chance that this happened completely by chance, which is, that's still 6 out of 100 times that this, could happen completely by chance, that this result would happen completely by chance. So just be aware of that we only have moderate evidence. So that is the end of 3B. Hopefully this is beneficial to you, and feel free to watch this as many times as you need in order to make sure that you understand what's going on.